This video is going to go over 17.1, evaluating functions. Here is the vocabulary for 17.1. If you've already looked up these words, please check to make sure that you have definitions that are close to these. And if you have not looked them up, please go ahead and pause the video and copy these definitions down now. They will be important as we go throughout this section. I want to make special note of the word function. A function is a relationship where each input has only one output. I want you to think about a machine whose function is to create chairs. Every day you input wood and you get a chair out. One day you input wood and you get toothpicks out. The function of that machine is broken. It is not a function if an input gives different outputs. All right, example 1 is asking us to evaluate these different functions. So in the vocab section, we talked about function notation. This f of x right here is just the name of that function. It's saying, hey, this is function f, and the input value for this is x. On question A here, we see f of 3. That's just telling you to plug 3 into the function f where you see an x. So I'm going to rewrite function f, but everywhere I see an x, I'm going to put a set of parentheses. This tells you what to put in those parentheses. I'm going to put the 3. Once you've plugged that number in, you use order of operations to evaluate and find the answer. Well, order of operations tells us we're going to do exponents before addition. So I start with 3 squared. After I get that done, I'm going to add. And so f of 3 equals 10. We're not going to be dividing or doing anything to try to get f by itself here. This tells us that when we input 3, we get 10 out. Take a look at example B. This tells us to plug -2 into function f. So everywhere I see a x in function f, I'm going to replace it with a set of parentheses. I'm plugging in -2. Same thing, I'm going to use order of operations. -2 squared is 4, plus 1 is 5. So I have f of -2 equals 5, which means when I input -2, I get an output of 5, and we're done. Question C says to replace x with 1. So this time in the parentheses, I'm plugging in a 1. 1 squared is 1, plus 1 is 2. So f of 1 is 2. That means when I plug 1 in, I get 2 out. Take a look at this second example. This gets into those bottom definitions where we talk about domain and range. So, domain is the set of input values, and range is the set of output values. Well, in ordered pairs, the input is the x value and the output is the y value. So to write my list of my domain members, I'm going to simply go down the list and look at all my x values: 2, 3, -1, 4, and 3. And I'm going to put those into numerical order with no repeats. You don't have to put them in numerical order, but I think it makes it easier later on to keep your work organized. So I'm going to go -1, 2, 3, and 4. Notice that 3 appears twice and I only listed it once. We do not repeat. Range is going to be our set of y values. So 1, 2, 0, 1, 2. So in this case, I'm going to do numerical order. I'm going to start with 0, 1, and 2. And 1 and 2 both appear twice, so I'm just going to have 3 values in my range. This last question asks us, is the relation a function? Well, in order to test to see whether or not a relation is a function, we want to know if each input has only one output. So I'm looking for repeating inputs. And I notice that in this point and in this point, both of them have the input of 3. But they also both have the output of 2, which tells us that every time we input 3, we get a 2 out. And that's the definition of a function. So since there are no repeats, yes, this relation is a function. The last example, example 3, asks you to complete a table and complete a mapping diagram for f of x, which is 3x minus 1. So to complete a table, if you recall, we're just plugging in x values where we see an x. So for negative 2, I'm going to do 3 times negative 2 minus 1. So that's negative 6 minus 1. So y is negative 7. Do the same thing for negative 1. 3 times negative 1 minus 1. We have negative 3 minus 1 is negative 4. Go ahead and try the next 3 values of this table doing the same thing. Pause the video, try them, and then unpause and check to see if you did it correctly. Okay, so now that you've unpaused, check to see if you have the correct values. If you do, you can move on. If you don't, check your work. And if you can't figure out where you went wrong, ask a question. Now that we have our table filled out, we're going to fill out a mapping diagram. A mapping diagram isn't as bad as it sounds. We're going to put our x values in numerical order, which they are already done, that's already done in our table. And then we're going to put our y values in numerical order. And for this one, they're already in numerical order in our table as well, but sometimes they won't be. Okay, so now I'm going to just map which output each input goes to. So negative 2 goes with negative 7. I'm just going to draw an arrow. Negative 1 goes to negative 4. Draw an arrow. Same thing with 0 and 1 and 2. Now, not all mapping diagrams will look like this. Sometimes you'll see the same input going to different outputs. Sometimes you'll see different inputs going to the same output. So they're not always going to be straight lines right across like this one is. Last question is the relation a function. Each input only goes to one output. You can see that clearly in your mapping diagram, which makes it very useful. So since each input has only one output, yes, it is a function.